Yeah. Okay. So good evening, everyone, and welcome on our workshop on secure storage with Ionic 2 and sqlcipher. I'm Steve. I'm a competence lead for Enterprise Mobile at Ordina Belgium. You see my Twitter and GitHub stuff up there, so nothing special. Agenda. So what would I like to talk about today? First, go over some prerequisites and stuff you need to install, and yeah, also tell you a bit about what you need to know in order to follow along. Do a mini introduction on Ionic 2, and then more specifically on the Ionic CLI. How do you generate projects with it, and all stuff like that? How do you run your apps that you generate with the CLI? Then talk a bit about problems that we encounter when securely storing data. So what do you need to look out for to be sure that you completely securely store your data and that there are no real loopholes in the process that you're working in? Then give you an introduction to SQLite and sqlcipher, and I prepared some exercises also. So there's a project somewhere on GitHub. I'll give you the URL later. Then also give you an introduction to the device's secure storage mechanism, and also prepared an exercise on that. And then give you a bit of a wrap up. So talk about what we saw and what potential next steps or things are that you can look at. So that's basically it. Come in. So yeah, prerequisites and stuff you need to install. I mailed you everything, but for the people following along at home, or the people that did not yet install everything, and here you go. So you need to install Ionic. In order to install Ionic, you also need Node and NPM. So how do you install that? Click on that link. Oh, maybe I should show you where the presentation is, then you can follow along. Might be easier to click on that link. I don't know if you can see this. github.com/ordina-jworks and then /secure_storage_ionic2_presentation. Typo. Yeah, there's a slides directory in there and just the index HTML, open it and everything should work. Yeah, download it and open it. Has anyone or everyone installed everything that I said you needed to install or not? Just so I know I can skip the part a bit. Yeah, if you didn't install it, too bad. So yeah, you install Node and NPM by clicking on that link and following the instructions over there. Install Cordova and Ionic afterwards. So once you install Node and NPM, you have the NPM command line utility. So you can just npm install -g for global Cordova space Ionic. That will globally install the Cordova and Ionic CLI tools that you need. Then because I will be developing for the Android platform and I will be creating APK files, we also need the Android SDK in order to compile our Android app. So the easiest way there is to download Android Studio. That's quite a large download, so I hope you already installed it or have it installed through another way, or yeah. Yeah, you need to set up some environment variables. Normally it's just setting up the Android home environment variable and adding the SDK tools and SDK platform tools to your path, and everything should work, like the ADB command line tools or yeah, whatever you need. Install an emulator, or you can use a physical device also. If you have your micro USB cables, you can plug your Android device in and just run the app on that Android device. Or you can use something like Genymotion or create an emulator after you installed your Android SDK through Android Studio. That's a really simple interface to just create an emulator, and you can use that one later. So that's a bit the prerequisites. Yeah, maybe what I should tell you also, what do you need to know? We're talking about Ionic 2. It's based largely on Angular 2, so you need to know Angular 2 a bit, not the really specific details about that. And also TypeScript, of course. All the examples are in TypeScript. So what is Ionic 2? Very simple. It's a hybrid app development framework that builds on the foundations of Cordova and Angular 2. Then we have Cordova, of course. What is Cordova? Well, Cordova is the tool that we use that will create our native application. So it basically wraps a native web view in a native application, and then it renders your web application in that web view. And Cordova also enables you to interact with device hardware. You have, through the Cordova plugin system, you can interact with basically anything the device offers, and there are a lot of popular plugins, like to interact with the camera, or to interact with a SQLite database, or to interact with secure storage. So everything you do normally through Ionic 2 is largely with Cordova plugins. Since it's a web app that's being rendered in a web view, it gives you more of a native feel because it's really an icon installed on your home screen or between your applications. So you really open it like a native application. So you get this bit of a native look and feel. Of course, you can render anything in that app and it can look crappy. So then it's not a native looking application, but yeah, that's what they try to achieve anyway. Yeah, then once you installed everything, you can start with Ionic, and here are some basic Ionic commands. So you basically normally start with generating a new project. It's just the Ionic start command that you use. You give an app name and you select a template, and just to be sure that you have an Ionic 2 project, you need to specify --v2. The --v2 is signaling the Ionic CLI that it needs to generate the Ionic 2 project. And it will give you an entire template application with TypeScript setup and everything. Template can be one of three things: blank, tabs, or side menu. Blank is really just an empty web view with nothing really in it. And you've got your tabs and your side menu where you already have tabs and a side menu, of course. It's not a lot of explanation necessary there. How do you build a project? You can just use the Ionic build platform command. So there are only two platforms that you can specify, iOS and Android. Normally the Ionic application works on Windows Phone also, but apparently, according to the documentation, I haven't tested it yet, there is no Windows platform. So should check out that in the future. Standard, when you generate a project in Ionic, generates a project and he already adds the iOS platform. So I don't have a command here, but when you want to build for Android also, you need to add the platform specifically. So you really need to say Ionic platform add Android in order to be able to do an Ionic build Android or an Ionic run Android. Otherwise, he will complain about the platform not having been added yet. Then you can serve a project. Serving the project is basically just serving it in the browser. So he really starts your local browser, runs everything in your browser, and the --live reload also watches your sources and will refresh your browser anytime you do a change. For our examples, it's not really usable because we are using some Cordova plugins that aren't available in the browser. So a lot of serving, there's no serving. Basically, it doesn't work. You can emulate the project by using the Ionic emulate platform command. So you just say Ionic emulate Android, and Ionic will build your application and deploy it on an emulator. Also, that's probably in my next slide. You can run the project. Basically the same command, Ionic run Android or iOS. He will package it. He will deploy it on a real physical device. And he also considers the Genymotion emulator to be a physical device. So if you want to deploy on Genymotion, you need to do Ionic run instead of Ionic emulate. Don't know why, but that's how it is. Yeah, you can find out a lot more on the CLI. On that URL. So definitely look into that one. You can also, you will see that in the CLI documentation, you can generate pages, which are basically your page components in your application. So that saves you a lot of typing. You can generate providers, a bit like you have with the Angular CLI. But I didn't really want to go into too much depth there. So that's for another workshop maybe. So that's a bit about Ionic 2. So now, why do we need secure storage? It's really simple. To comply with security or privacy regulations, to avoid claims in case of data breach, to avoid reputation loss in case of data breach. So you have to know that once you're developing mobile applications, you're targeting a potentially very large user base, and you don't have control of the devices which they are using and where your software runs on. So you will be storing data on those devices, and you have absolutely no control over that. So you want to secure that a bit, especially if you're using applications, for example, in the medical sector where they use medical data. There are quite some strict rules on what you store on those devices. And I can imagine that in the financial world, it's the exact same thing. So you don't want any data breaches. So that's why secure storage is important. And what are the problems that we encounter when we want to securely store data? But that's not really a problem, but storing data is really easy. So on Android, on iOS, there are a bunch of mechanisms that you can use to store data. But the thing is, yeah, you can't see it in here. Those are all very easily breached, and it's mostly readable data. So once you're able to back up the application, or using tools like ADB, for example, to really create a shell into your device, you can just run as your device, the UID of your device, and then you can just browse the data that has been stored. So if you store shared preferences, if you store plain files, it's just readable. You can open them and you see everything that is stored in it. SQLite database, basically the same thing. It's not readable, but once you have the SQLite CLI, or you have the SQLite browser utility, then you just open that database and you start browsing around, and you have all the data that you want. That's something you might not want to happen. So how is that even possible? Yeah, it's very simple to do that. You can basically just back up your app. Devices are being rooted or jailbreaked all the time. So what happens there is that instead of running in a sandbox where one application does not have access to all the resources of another application, that those sandboxes are just gone. There's no notion of a sandbox anymore, so you can access everything that you want. So that's why we also need to store securely our data, because we don't have control over the end user, and he might have a rooted or jailbreaked device. How do you back up your app? Again, there's a very good tool available. You can find more on it on that GitHub link. It's the Android backup extractor. So you just you use ADB to perform a backup. So you say ADB backup app package name. He completed that tag, so it's just the app package name. This not the second app package name. That's a typo in the slide. And the app package name, you can find that in the Android manifest file. So you open your Android manifest, and there's a package name in there, and that's the package name that you need to put in there. And then you do ADB backup. I'll show you later how you do that. And you get in a .ab file, backup.ab, and then you can extract that file. The AB file is not accessible. Then you extract it with the Android backup extractor, and you just get a tar. And then I double-click the tar on my Mac. I suppose on Windows you can get a zip or anything, but whatever. And then I just open the files in it and watch what's in it. Not escape. So how do you do that? I have my Pruts folder here. It's my, and the device is offline, so I need to restart because I waited too long. So I'm going to start the emulator again. Set up my stuff a bit too early, so now everything is failing. It's odd. So it really was correct, but somehow the first time he thinks it's not correct. The pin thing is necessary for my demo in a few minutes. Voila, so it was actually correct. Stupid pin thing. I back up my data. Is it this one? Yes. So the next thing I do is use this backup extractor thingy. So these are the commands that I just showed you in the presentation. He creates a tar of this. And there you have all your data. You have your database. You have databases which contain local storage that you saved in your browser. You have other preferences, which we'll go into a bit more in detail later, because this is actually an encrypted database key, so it's readable, but you can't read it. And other preferences, it's all plain readable. So that's how you create a backup and extract it and just access everything that's in it. I would show you the contents of the database, but I'm on the latest branch of my exercise, so it's already encrypted with a password that I don't know. It's 44 characters, so we cannot really guess it. Yeah, but all these problems can be solved. And the part I'm going to show you now is a part of the solution, but not the entire solution. Yeah, using these things, sqlcipher, keychain, or Android key store system. So a combination of two, actually, because the keychain is for iOS and the key store system is for Android. Combination of these technologies will allow you to securely store data on your device with a password that they cannot find or retrieve, or they shouldn't be able to find or retrieve. You never know how creative these guys are. So sqlcipher, what is it? It's a drop-in replacement for SQLite. It's a AES 256 encrypted, so that's pretty heavily encrypted. It's password protected, so you supply a password when you create a database. This thing will generate some sort of AES key, I guess, and then it will just encrypt it block per block. It's available on all major platforms, so iOS, Android, or Windows Phone, they all have SQLite. So using sqlcipher, it's actually really a drop-in replacement. You just drop it instead of the SQLite and you have sqlcipher. It's really simple, even simpler in Ionic than you do it native on Android. Yes, how do we use sqlcipher? Well, through a plugin, of course. That's where Cordova comes in. So the first link is the location of the Cordova sqlcipher adapter. And you install that plugin using the command line Cordova utility. So in your project, you just say Cordova plugin add the Cordova sqlcipher adapter -- save. So he saves it in the correct file so that when you check in the project and someone else checks it out, when they add the platform, he will add the plugin for you. So you don't have to commit the plugin contents, which is handy because it saves you some space. How do you use the plugin in your Ionic TypeScript code? Well, the plugins are registered through your main window object or your global object, and TypeScript is kind of, as well, strict in the sense that when you want to use the SQLite plugin and it's not declared or imported, then he will start to complain that your code isn't working. So you need to declare it on top of your TypeScript file somewhere where you want to use it, just to instruct the compiler saying, hey, this thing is available, I know it's available, so stop complaining about any compilation errors that there might be when you see this. Yeah, then there are some basic commands that you need to use to start working with this thing. There are a lot more on the GitHub documentation. I'm not going to show you all of these. But so you can basically open the database, you give it a name, you give it a key, which is a variable here, but it can be plain text string. That would be not so wise because it's also easily retrieved when they reverse engineer your application. And location is default. I must say I don't know by heart which are the other ones, but default is good location, so put it at default. Yeah, you can select data, you can modify data, so all the API things are explained on GitHub also. But once you open a database, you get a database reference that you can use, and on the database reference you can use the execute SQL or execute SQL command. It receives 3 parameters. So the first one is the query string that you want to use. The second one is an array with values for your placeholder variables that you have in your query string. So in your query, I will show you later in the code, you can put question marks. So that you don't have to concatenate your string with those values. And the second array is used to supply values for those question marks. And the third one, argument, is a callback, which will give you the result set and which you can loop through, and you can map your records from the result set to your actual objects that you want to put in an array or whatever and display on screen. The resolves here are a bit of a, that's something I do. So all this asynchronous stuff, I just return the promise, and once the callbacks are being called, I resolve with my value the promise that you will see later in the code. It's maybe not so good to explain it right now, but so what you don't see here is, here I create a new promise and here I resolve it with my value. It's really easy. This is also something that Reveal.js is putting there for some reason. I have no clue why, but don't mind the patient tag there. Modifying data is practically the same. I just wanted to show you how you do it here with transactions, because when you do multiple modification statements, you want a transaction to either commit or roll back in case of failure. So it's really just starting with a db.transaction call instead of db.execute SQL directly. Then you get a callback with that transaction, and then you can execute your SQL on that transaction reference. So it's just one extra call to make sure that you run all your statements in one transaction. The arguments are basically the same. You have your query string, you have your placeholder values, you have a callback which now receives the transaction and a result set, where again you can do something with your result. For example, I can ask the result for the patient ID. No, that's wrong. That should be insert ID in this case. Yes, patient ID is not correct, I guess. So that means that I can create an object, I say save it, the thing saves it, gives me an auto-generated ID, and then I put it back on my entity and I resolve the entity. It's again with the promise that I use to wrap that call. There's also an error handler. I think that in the select version there's also an error handler where you can log whatever error thing that you want. You can resolve, you can reject. I resolve with an empty object for some reason because my logic expects that. So that's how you work with that API. You can also use execute batch, where you can really execute multiple statements in batch. I use that, for example, to create my database schema, just to have all the create tables in one batch and execute those. I didn't show it here. Everything you need to know about sqlcipher is you can find at those two GitHub links. So you have sqlcipher, and everything that you don't find in the sqlcipher plugin, you just go and look in the SQLite plugin documentation. It applies to the sqlcipher also. The largest difference between sqlcipher and SQLite is that when you open a database, you have a key option which you can specify as your database password. Why didn't I use Ionic Native? Because Ionic Native wraps a lot of Cordova plugins, and they wrap them with promises for you, which is very handy because the Angular 2 system will monkey patch all those promises and will trigger like change detection systems for you. So he will update his user interface whenever a promise is resolved. So using Ionic Native, they wrap all the Cordova plugins with promises, and that way the Angular system is able to detect your changes. I didn't use it because I could not specify key property. That was one, and it is very poorly documented. Do I have it here? No. Maybe I should open it. Okay. SQLite usage. That's one thing that they show, and then you have this. And from my tiny bit of experience that I have with this, it didn't really work that well. Even with this amount of documentation, I tried some of these calls, it didn't work. The open database thing, also didn't really open my database. I had a lot of issues with it, so I decided not to use Ionic Native. I do use Ionic Native whenever I need to detect network connectivity, or whenever I need to detect or use the camera, for example, all that stuff. Therefore, I use Ionic Native. So where was I? Hand on, no. Stuff you need to install, Ionic stuff. Oh, I think I was at the end of this, no? Yeah, this can be solved. Oh, this is annoying. Okay, yeah, and then exercises. So I don't know if you want to do some exercises right now, or if you want to wait for the second part of the theory. I can do the second part of the theory, and then we can do all the exercises at once. I'll do the second part. There's a lot of feedback coming from you guys. So that's all very nice. We can now securely store our data with a password that is just plain text in our code, so it's not secure at all. Someone with 10 minutes of time who knows his way around a bit will probably get your password very fast. So the next thing is to store our password somewhere where it's safe. And then again, we're relying on a Cordova plugin. And this time it's the secure storage plugin that we will rely on. So you install it in the exact same manner as you did with the sqlcipher plugin. You do Cordova plugin add, Cordova plugin secure storage. You get the plugin installed for all your platforms, and you can start using it. Again, like you did with SQLite, you need to do this declare thing on top of your source file to really be able to access it. How does it work? Yes, it's a bit technical, but on Android he will do a lot of things for you. So he will create a random 256-bit key that is generated, and then the AES key will encrypt your value. So if you say I want to store my password, then the 256-bit key will encrypt that my password string. Yeah. Then the AES key is being encrypted with a device-generated RSA key with this cipher suite from the Android key store. So the Android key store is something that you have in Android. In more recent versions, it's really hardware backed also, where you can generate keys So your application can generate a key, and only your application is able to access that key afterwards. The key cannot leave the secure storage or the Android key store because it's backed by hardware, so the key remains on the device. So you generate a device-generated key, and then the combination of that key and your encrypted my password value are stored in shared preferences. That's correct, huh, as I say it? No, the combination of the encrypted AES key and the value are stored in shared preferences. So then you do the reverse operation again to decrypt everything. So you go and access the device generated key, you decrypt all your values you had before, then you have the AES key, then you decrypt your password string, and then you have your plain password back. Yes, two important things to note when using the secure storage plugin on Android is that it only works when your device security is enabled. So that's why I need to do the stupid pin swipe thing for my demo, because otherwise the secure storage does not work. It's not due to the plugin, it's really Android that wants you to have a secure device when you want to store device-generated keys. So you cannot do that. And the second one is maybe even more annoying, is that when you change the device security, your device-generated keys are all gone. It really wipes your Android key store. So that's something that I will need to figure out how to solve. Maybe we should back up our keys on the server anyway, just in case someone changes his PIN code or swipe code, because it really wipes all your keys, so database is inaccessible, and maybe you have some important stuff in that database that you don't want to lose. So that's a bad thing. Yeah, on iOS, it's a lot shorter, the description. There you have the keychain where you can put stuff in, which is pretty secure. The FBI already found out that it's not really easy to extract stuff from your iOS device. So it's basically, that's what behind it. How do you create secure storage? So let's assume that you did the declare thing on top of your TypeScript file. I think the Cordova.plugins, you can ignore that. You can use the secure storage once you declared it. And you just create a new secure storage. That's it. And then you get a success callback when it's created, and you get an error callback when it's when something goes wrong. And this is the app that this is the name that you give your secure storage. And then once it's resolved, you have your SS, you have your secure storage, and then you can start storing stuff through that reference. So how do you get a value from it? No surprises there. You just do a get. Again, you have the success callback and the error callback, and you say you want to get the my key string value, so the value that is represented by that key. Setting, the exact same thing, only supplying a key and a value in that case. Again, with success and error callbacks. So what I did again was wrap all that stuff in promises, so I could chain the fact that I created my secure storage, and then I resolve my secure storage in the success. And in the then of the, once I resolve it, and the then from the creation, I can say, okay, now put a key in it. Because otherwise you have this asynchronous stuff going wrong, and you try to set keys on secure storages that have not been created. So it's all the asynchronous stuff in JavaScript. It's needs some getting used to, for me at least. So, and also I have some exercises for that. So that's the theoretical part of storing securely all the stuff. So we can do the exercises now, or we can wrap up. Maybe we should wrap up first, and then the people at home can also start doing the exercises. I will show the GitHub repository, and then we can, have some fun. So wrap up. Storing your data in an encrypted database can be done with sqlcipher. We saw that. It's just installing the plugin, opening your database, make sure that you create a schema and everything, and just start interacting with it. Then, of course, your database key needs to be stored also, and then also somewhere that they cannot get it or retrieve it. And there's actually 3 ways that you can do it now. We are going to see one way, because the other 2 are fairly obvious or easy, so they don't really need any explanation. You can store it in a device secure storage, which we also saw how you do it, and which is backed by a lot of encryption mechanisms, and which is mostly hardware backed in the latest devices. So the key normally cannot leave the device unless you root it, but you can detect for root and everything. You can ask the user for the password every time your app starts up, but I don't know how you guys feel about it, but user experience wise, it's not fun to use apps that constantly ask your password just to decrypt your database. But it's a safe way, because they really need to start waterboarding you or something to get your password, and even then. And then you can store your database key on the server, also just because it wouldn't be on the device. So of course they can hack your server, but and that happens. But at least they can't retrieve it through your device. They have a lot more of control over the devices. But the downside of this is that every time your app starts up and it needs a decrypted database, you need an internet connection. And the other situations, you can really offline use your application because the user supplies the password or it's in the secure storage on the device. Yeah, sqlcipher, working directly with sqlcipher plugin causes a few problems. Problems is saying a lot, but the code is very verbose. It reminds me of the early days when I used Java JDBC directly. It's a lot of boilerplate stuff happening. I couldn't test it in the browser using my Ionic serve command because he was complaining about the SQLite plugins not being available for the browser. Yeah, and sqlcipher is just a SQL database. Usually when you start storing stuff offline, you also want that stuff to get to the server someday. So there's no syncing between client and server. It's a manual job, so you really need to manually start writing your sync framework. That's a lot of work. It's tedious and error prone, of course. There's libraries that do that way better than you do that. Then there's also secure storage. That's a means to store data on your device in a protected manner. However, it remains the safest if you do not store your passwords on the device, not even in secure storage. Now and then there's errors or loopholes that they found in the operating systems which allow them to actually access the keys, and then you're off to where you started actually. So, and also some regulations actually forbid you from storing passwords on the device, like the HIPAA regulation. It's some health sector regulation from the United States, which normally states that when your app starts up in airplane mode, then it's not HIPAA compliant, because then it means that you have stored data offline, that you are able to open your database offline, so then that's already non-compliant. Alternatives to all this stuff. Maybe we should do a second or a third workshop afterwards, and looking more at PouchDB. So PouchDB is definitely worth a look at. It can sync with CouchDB. It has a way nicer API, and it uses some form of storage mechanism extraction. So it will check, is there a SQLite plugin available, and if you want to use that, then he will use that one. If it's not available, he will fall back to browser databases like IndexedDB or WebSQL. So there's a lot of fallback mechanisms there. And as I said, you have the sync out of the box that works. If you have a CouchDB on the server side, of course, it syncs everything for you. And has a nicer API. And plain PouchDB isn't ideal yet because it's all about key values that you store, and there's not a lot of query possibilities in it. But using PouchDB find, you should already move along quite an end with that. And also PouchDB rel, which allows you to step away a bit from the key value storage mechanism, but it still remains a key value store, but the PouchDB rel is a layer on top of it, which allows you to access it a bit more in a relational way. So you can define a schema in a more relational way. You can define relationships between entities, and then using PouchDB find, you should be able to have extensive query mechanisms also. More a MongoDB style query library that you get. But that's all in the PouchDB rel, I don't know, but the PouchDB find is in beta, so it wasn't really usable for me at the moment, so I didn't include it in the workshop. And the PouchDB then I didn't really include because of the lack of query mechanisms. Well, you might say that you just fetch all the documents and you use all the operators that you get from RxJS. That's a possibility, but I'm not sure performance-wise if that's a wise choice. But so that's basically how you securely store stuff on your device with Ionic 2 and sqlcipher and secure storage plugins. So I suppose that we will create some exercises now. And you can find these exercises here on GitHub, ordina-jworks/secure storage Ionic 2 with some underscores between it. And when you check it out, you will see that there are 3 branches. There's an exercise. No, I have to watch out what I say. There's an exercise, create database connection and something, something, something. And then I thought like maybe I should call it exercise 2 and 3. So the next ones are 2 and 3. So the first 2 are to set up your database and to fetch your data from your database. And the third exercise is an exercise to store your password in a secure storage. You need to go through the commits a bit, but the files that you need to modify, you have those instructions of your exercise just in a comment in those files. Voila. So now we are going to do the exercises. So I should say start, and if there are any issues or questions or anything else, ask me, and I will answer them. Good? No, 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 no. It's not necessary. Allez, you can, but